This is part 1 of lecture 1.5 of Math 108, Predicates and Quantifiers. In this video, we will learn how to find the truth set of a predicate. We begin by recalling some concepts related to sets. We will study sets in more detail in parts 3 and 5. For now, we will use only elementary facts and definitions which you have learned in previous math courses. A set is a well-defined collection of objects. Some special sets which we shall frequently refer to are the universal set, which, depending on the context of study, consists of all objects under consideration. Whenever applicable, we will always specify the universal set that we will use. The null set or empty set is the set with no element. Throughout this course, we will denote the universal set by the cursive letter U and the empty set by a circle bisected by a diagonal line. The following are basic relationships between sets. A set A is a subset of a set B if and only if all elements of A are elements of B. This is the relation of set inclusion. A set A is equal to a set B if and only if all elements of A are elements of B and all elements of B are elements of A. This is the relation of set equality. By default, every set under consideration is a subset of the universal set U. The null set is a subset of any set. We will prove this second fact later in the course. The union of two sets A and B consists of the combined elements of A and of B. That is, all objects X in the universal set with the property that either X is in A or X is in B. The intersection of sets A and B consists of all elements common to A and B. That is, all objects X in the universal set with the property that both X is in A and X is in B. The difference B minus A, also called the complement of A in B, consists of all elements of B which are not in A. That is, all objects X in the universal set with the property that X is in B but X is not in A. The complement of A consists of all elements which are not in A. That is, all objects X in the universal set with the property that X is not in A. The complement of A is equal to the set difference U minus A. Recall that a predicate is a statement that contains variables that represent unknown objects, and that becomes true or false when the variables are replaced by specific objects. A predicate has a truth set which we shall define shortly. For example, the statement x squared equals 1 is a predicate with variable x. Replacing x with 1 gives the proposition 1 squared equals 1, which is true. Replacing x with 0 gives the proposition 0 squared equals 1, which is false. We will often denote a predicate P with variable x using the notation P of x. The truth set of a predicate P of x is the set of all objects in the universal set U that, when used in place of x in the predicate, turn the predicate into a true proposition. That is, the truth set T of P is the set of all objects X such that P of x is true. For example, let P of x be the predicate x squared equals 1. Assuming that the universal set is the set of all real numbers, we see that 1 belongs in the truth set of P and 0 does not belong in the truth set of P. Indeed, the truth set of P is the set consisting of the numbers 1 and minus 1. Predicates can also be put together using logical operators to form longer predicates. We give here the truth sets of predicates formed using each of the basic operators. Assume that P and Q are predicates with variable x. The truth set of the negation of P is the complement of the truth set of P. Indeed, the truth set of the predicate not P is the set of all objects X such that not P of x is true. Not P of x is true if and only if P of x is false. P of x is false if and only if X is not in the truth set of P. The set of all such X is the complement of the truth set of P. We shall leave the derivation of the other truth sets as an exercise. The truth set of the predicate, either P or Q, is the union of the truth set of P and the truth set of Q. The truth set of the predicate, both P and Q, is the intersection of the truth set of P and the truth set of Q. The truth set of the predicate, if P then Q, is the union of the complement of the truth set of P and the truth set of Q. To illustrate, assume that the universal set is the set of real numbers, and let P of X be the predicate, the absolute value of X minus 5 is less than 3, and let Q of X be the predicate, the absolute value of X minus 5 is greater than 3. You learned in high school algebra that the absolute value of X minus 5 is less than 3 is equivalent to the predicate X minus 5 is greater than negative 3 and X minus 5 is less than 3. Thus, the truth set of the absolute value of X minus 5 is less than 3 is the intersection of the truth set of X minus 5 is greater than negative 3 and the truth set of X minus 5 is less than 3, which are the set of all real numbers greater than 2 and the set of all real numbers less than 8, respectively. Hence, the truth set is the open interval from 2 to 8. The predicate, the absolute value of X minus 5 is greater than 3, is equivalent to the predicate either X minus 5 is less than negative 3 or X minus 5 is greater than 3. Thus, the truth set of the absolute value of X minus 5 is greater than 3 is the union of the truth set of X minus 5 is less than negative 3 and the truth set of X minus 5 is greater than 3, which are the set of all real numbers less than 2 and the set of all real numbers greater than 8, respectively. You have come to the end of Part 1 of Lecture 1.5. Before you proceed to Part 2, you are strongly encouraged to do the exercises given at the end of these slides. Thank you for your attention.